Hello children, now welcome to our next class and today we will proceed to the second law of motion. Newton's second law of motion is very vital in mechanics because this law helps us to derive the expression of force. Second law of motion. Before that we will discuss that what is the need of second law of motion. Second law of motion has originated due to the failure of first law of motion. What was the limitation of first law of motion? First law defines the force, but it can't measure the force because we have not any expression for that. So first law is known as law of inertia, and when Newton sir come to know that the limitation of this law is not elaborated properly by this concept because he has missed the concept of momentum there. So Newton sir has added the momentum and he has designed the second law of motion. So what is the statement of second law of motion? The rate of change of momentum is directly proportional to the force applied. The rate of change of momentum, the rate of change of momentum is directly proportional to the force applied and inversely proportional to the acceleration. So, and rate of change of momentum is directly proportional to the force applied, and acceleration takes place in the direction of force applied, and acceleration takes place acceleration takes place in the direction of force applied. Please split this law into two parts. The first part is stating that what is the nature of change of momentum. So the first part is telling the rate of change of momentum is directly proportional to the force applied. That means the more you apply the force, the more fast the momentum will change. If I am throwing this marker with the speed of first case like this one, second case like this one, and third case like this one, in which case the marker will be thrown for more distance? Obviously on the third case, because on third case we have applied more amount of force, so the change of momentum will be also more. And in which direction the marker will be thrown? The direction on which we are throwing it. So the acceleration will take place in the direction of force applied. So the rate of change of momentum is directly proportional to the force applied, and acceleration takes place on the direction of force applied. Further, Newton sir has derived this law, and he has derived for a body on the motion. So let's move for the expression of force. Expression of force is governed by the Newton sir, and he has defined that expression of force, expression for force. So he has considered a body in motion. Let a body of mass m is moving with, the body is in motion, let a body of mass m is moving with initial velocity u, and due to uniform acceleration a, it has attained final velocity v at time interval t second. So please listen the condition. The body is in the motion with initial velocity u, and due to uniform acceleration, that means force is working, so that acceleration will be there. Without force we can't change the acceleration. Due to uniform acceleration a, it has attained final velocity v at time interval t second. So when force is working on the body, then the body's momentum will always change. So suppose let initial momentum is mu, and final momentum is mv. So what is the change in momentum? So change in momentum is directly proportional to mv minus mu. This is the change in momentum. Now change in momentum with respect to, this is with respect to time, is mv minus mu by t. May we write so? And according to Newton's rate of change of momentum with respect to time is known as force. So in place of this change in momentum with respect to time, we write force. So force is directly proportional to m, we are taking common. Now here v minus u by t. So it's a v minus u by t. Further we write f is directly proportional to m. Now v minus u by t, we have learned a quantity. Which quantity that is? Yes, that is acceleration. So in place of that we will write ma. So f is directly proportional to ma, or we will write that, or f equal to kma, where k is a constant known as proportionality constant. K is proportionality constant and its value in SI system is always 1. The value of k in SI system is always 1. So we may conclude it that f equal to ma. So with the help of Newton's third concept, we have derived the expression of force, and force is directly proportional to mass and directly proportional to the acceleration. So the advantage of second law of motion, it helps to derive the expression for force. If anybody will ask what is the significance? What is the significance of first law of motion? First law defines force. What is the significance of second law of motion? Second law measures force. Second law measures force. So please pause the video and write down the thing. It is expression for force. So dear student, please try to learn the definition of second law of motion and try to derive this by your own by putting the required condition. Till then, thank you.